Hello, my name is Caio Rocha. I am 28 years old and I work as automotive engineer. I graduated as a mechanical engineer, and this is my CS50 final project. I try to bring the knowledge I took from this course just to apply in my field of study. Here I use the Streamlit. That is a pretty straightforward uh, front end in this case. I'm gonna explain this quickly. I don't think that 3 minutes are enough for me to explain the details of this. But basically, inside the industry, we have the coast down test where we calculate the road load coefficients, and this is applied by a bench roll where you put the vehicle and measure the emissions or the energy spent, depending on if this is an electrical vehicle or a mechanical vehicle, IC vehicle. So here we have all the methodology. This really has several pages. We have all the methodology here. This is available in GitHub, so my README inside there is the right link. I intend to apply this as a future paper, a future publication. So I'm using all public data sets. In this case, I had the EPA available. I still had to look for these other ones, but and here at the homepage we have also the roadmap, the things that I intend to do. I intend to apply ML to determine some coefficients in the future. So okay, so let's go for all this program does. First, I had to set the database. I had to pre-process it from the original one from the EPA. But in this case, we have a call VDE setup where you can actually identify the vehicles, or you can pick a baseline for doing stuff with it. In this case, we can apply deltas from the rolling resistance, for example, deltas with the aerodynamics, delta with the brakes, delta with the parasitics, and delta mass. That we have a calculated VDE for each one of those roles, but here we have a snapshot of how they are going to be calculated by on this time. When you use we can use a default cycle. Here we have loaded both EPA cycle and WLTP cycles. You see it brings us the snapshot. So finally you save it. And you bring this. I was missing the fields when I say the general vehicle data, so you cannot choose. I just create this line. You can see here. This one is saved. All the data, all the important data actually. There's legislation and the VDE. So after we define VDE, so here at our next tab, that is the powertrain fuel energy, we take this set, this VDE set. We consider the electrification and the user transmission global efficiency. And we have the possibility to view all data sets, all right? When you can see here that all the vehicles certificated by EPA are here. We have the hybrid, the full hybrid, and the PHEV that are much more efficient than the ICEs and mild hybrids. And here we can see that the power of the vehicle affects the fuel economy. You can actually use your VDE to calculate it. So you can use the calculated by parameters, as you see here. You set the efficiency based on VDE, all right? And you get an efficiency, all right, for this. You calculate all this and goes to your database. These are extra scenarios that are actually include future analysis that I intend to do. And this is a regression when you can filter vehicles that you want to actually consider for your analysis. Let me say that you have a hybrid electric vehicles and you have a high power, for example, over 700 horsepower. So based on this, it calculates the regression and gives you a final set, all right? And this can be saved in your data set, all right? This will be saved in your data set. So that's it. You estimate it, a fuel consumption for this. This is already on the data set, and that is my final report for this project. For now, I intend to do more stuff. Thank you, and I appreciate a lot taking this course.